Good morning, sir. Ramesh.
Hello, good morning. Can you hear me?
Yeah. Can you hear me, sir? Yeah.
Yes.
Yeah. Thank you, sir. Thank you for joining.
No problem.
Sir, good morning, sir. Ramesh Singh, sir. I'm HOD Mechanical, Satish.
Nice to meet you.
ವಾಯ್ಸ್ ಬರ್ತಾ ಇಲ್ಲ ವಿಡಿಯೋ ವಾಯ್ಸ್ ಬರ್ತಾ ಇಲ್ಲ ಇಲ್ಲಿ ಬರ್ತಾ ಇಲ್ಲಪ್ಪ ಆಕ್ಚುಲಿ
ಸಂಗಮೇಶ್
ಬರ್ತಾ ಇಲ್ಲಲ್ಲ
Yes.
ಸಂಗಮೇಶ್ ಹಲೋ ಸಂಗಮೇಶ್
ಹೇಳಿ ಸತೀಶ್ ಕೇಳಿಸ್ತಾ ಇದೆ
ಸಂಗಮೇಶ್ ಅಲ್ಲ
ಕೇಳಿಸ್ತಿದೆ ಸಂಗಮೇಶ್ಗೆ
ಬರ್ತಾ ಇಲ್ಲ
ಟ್ರೈ ಮಾಡಿ ವಾಯ್ಸ್ ಬರ್ತಾ ಇಲ್ಲ
Good morning, sir. Excuse me, sir. You're not audible, sir. The voice is not. We not able to hear.
Good morning, sir. ಬರ್ತಾ ಇಲ್ಲ ಸರ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ Well, good morning, all of you.
Good morning, sir.
Very good morning to all of you. Sir, shall we start, sir? With your permission. Principal, sir, shall we start, sir?
Just hold on for a couple of minutes.
Okay, sir, thank you.
99455.
Yes.
Sir, not heard. Not
Yes, sir.
heard.
Not heard.
Not audible.
Jyoti, please check.
Yes, sir. Sir, shall I play the video?
You play the video, but where is the audio there?
I will check this.
Yeah.
Sir, now it is audible.
Madam. Hello, Jyoti madam.
Haan, sir. Haan, sir.
If you have an access, you please play the video, madam. Maybe some issue we are finding it here. If possible from your side, you please play the video.
Okay, okay.
Thank you.
Is it fine, sir?
madam.
That's correct.
Institute of Technology and Management has a very vast, green and serene campus in Yelahanka, which is close by to Bangalore International Airport. BMSITM is a part of proud group of institutions called BMS Group of Institutions, which is responsible for starting the first ever private engineering college in the country, and the college was BMS College of Engineering, Kasur. We are so proud to be a sister institution of BMS College of Engineering here in Bangalore. The biggest strength of BMSITM is the highly innovative and effective teaching learning processes. Our institution has got state-of-the-art laboratories, academic as well as support infrastructure here. And we have a DST, Department of Science and Technology sponsored Advanced Materials Research Lab functioning. In fact, many institutions both in Karnataka as well as outside Karnataka are utilizing the services of these facilities here. We are practicing outcome-based education, which is of the order of the day in internationally reputed institutions. The idea here is to impart the kind of competencies and behaviors that are necessary in students to excel and solve the problems, complex engineering problems that may be there in the society as well as industry. Everybody who comes in contact with BMSIT, I'm sure they'll be relishing and enjoying their association with the institute here. You are most welcome to this institute at any point in time.
Sir, shall we start, sir?
Yeah, please go ahead. Yeah.
Yeah. Okay, good morning to all of you for the today's program. We welcome on behalf of BMSITM for the international webinar on global perspectives of engineering. Well, the essential outcome of any academic pursuit, apart from imparting knowledge, should aim to bring together complementary streams of activities to develop knowledge-driven society for the benefit of society in large. There are many reasons to believe that increased educational opportunity and achievement lead to social progress, and BMS Educational Trust is known for its charity since from its inception. BMSITM believes that education can be a vehicle for equity and greater social inclusion, or when absent, poorly delivered, or unfairly distributed, a vehicle for injustice and greater social exclusion. To begin with, most people don't know what they are getting into when they are opt for engineering after 12th. A large percentage of people does it out of parental or peer or societal pressure. People are told things like you have 90% in 12th, you must take engineering. And if you have only 60 or 65% in 12th, you are fit for commerce. Or if it is in a range of 50%, then probably you can fit for arts. So much of it is related to parents or family prestige. हिंदी में कहावत है हमारी बिटिया इंजीनियरिंग ही करेगी. So keeping this in mind, BMSIT come up with a very unique online program that is International Webinar Series on Global Career Prospects. This webinar series is being organized by BMSITM as a part of its social responsibility. This webinar has been designed and developed for all 10+2 students who are aspiring to pursue engineering program, which helps to make a right choice of the program of study. Also, many internationally reputed professors, speakers have been invited and will be speaking on different branches of engineering in the next 1 week of its time duration. And they will be expose you to the importance, recent advances, R&D, scope for application, career prospects, etc. in various branches of engineering, so that students who are aspiring for engineering will be able to make a correct choice for your career. Today we have with us Professor Dr. Ramesh Singh, Senior Professor of Mechanical and Material Engineering, University of Malaya. Also we have with us Dr. Dr. Mohan Babu GN, Principal, BMSIT and M. Also we have with us Dr. H.K. Govind Raju, Vice Principal, BMSIT and M. Also we have with us Dr. K.M. Satish Kumar, Head of the Department, Mechanical Engineering. So today's first day session will be on awareness program for mechanical engineering aspirants. So I welcome you all the participants and all the guests of the today's function. Now I request our Honorable Vice Principal, Dr. H.K. Govind Raju sir, to welcome and introduce the chief of the guest of the today's function. Over to you, sir.
Thank you, Sangamesh. Good morning, all of you. It is my present duty to introduce the guest of the today's function, Dr. Ramesh Singh. Well, before that, we have taken this program as a social responsibility to give an awareness for the students on higher education to select their best choice of engineering. That is that objective. We have floated this webinar series for this whole week. Today we have from the Department of Mechanical Engineering, we are organizing this program. So on this occasion, we are with the consent of the principal. Principal insisted to go for an all international speakers on this occasion. So I requested Dr. Ramesh Singh to be speaker of today's function. On our request, certainly Ramesh Singh has accepted to become a speaker on this occasion. He is with us today. I take this opportunity to welcome you, sir. And this is the right time to introduce Dr. Ramesh Singh. He is a professor, Department of Mechanical Engineering, University of Malaya, Kuala Lumpur, Malaysia. He graduated from BSc Engineering Honors in Mechanical Engineering and PhD in the area of ceramics from the University of Sunderland, UK. He has contributed immensely to the development and enhancement of science and technology in Malaysia, particularly in the field of ceramics engineering. He published more than 300 research articles in various ISI, Web of Science, Scopus Index publications. Along with this, his research group has secured more than 15 million ringgits of research funding from numerous projects relating to materials development, advanced manufacturing, and machining. Ramesh Singh has filed numerous patents for his innovations and received many honors as a distinguished scholar. He is the recipient of prestigious awards. In his credit, he is having IEM Young Engineer Award, MTSF Science and Technology Award, and won more than 55 awards at international and national exhibitions pertaining to his research and innovations. He is recognized as one of the 12 top Malaysian engineer stars by the Institution of Engineers Malaysia. Professor Rameshin is a fellow and chartered engineer with the Engineer Council in UK, Australia, and Malaysia, and more than 5 international associations. He is he is serving at various capacities in Malaysia as a professor, associate director for NAC Accreditation Board, professional mentor, resource person, external examiner, advisor, and and also a member of engineering accreditation panel. His contributions are numerous for in the field of academics. Apart from all these things, he is working for upholding the standards and quality of engineering education in Malaysia. This is his dedication for the education development in Malaysia. With this brief introduction, I welcome you, sir, once again for our webinar series.
Thank you, sir.
Thank you, Ramesh. Along with us, we have our principal, Dr. Mohan Babu GM. With this, during this period, the institution has got NBA accreditation, NAC accreditation, and we are looking forward for autonomous. Shortly in the coming days, the institution is going to become an autonomous. Now, presently, we are working under affiliated system. With this great achievements and contribution to the college, I would like to introduce Dr. Mohan Babu. Dr. Mohan Babu is graduated from Malnad College of Engineering, Assam. After his graduation, he completed his master's from Indian Institute of Technology, Madras, and PhD from Indian Institute of Technology, Madras. He got very vast experience in the field of academia. He has more than 30 years of teaching experience. He served at Malnad College of Engineering. He served as an head of the Department of Industrial Production and Engineering. And later on, he joined MS Ramaya Institute of Technology. It is one of the prestigious institute in Bangalore and Karnataka. Presently, he is working as a principal of BMS Institute of Technology. He has several awards and honors in his credit. He got international doctoral fellowship from the United Nations University, Netherlands. His project has been awarded, PhD project has been awarded national. He got a national award from Transport Corporation of India Foundation, India. Recently, he got one of the award, Rex Karmavira Award from one of the biggest social organization of India. for his academic credit, he participated and contributed a lot of things to the EduSat program from the University Visvesvaraya Technological University. And also, he worked as a subject expert, NPTEL, National Project on Technology Enhanced Learning. He worked as a subject expert at IIT Madras. And also, he served in various capacities in Board of Studies, Board of Examination, with a committee member, as a committee member, from the and Joint Board of Examiners, Joint Board of Studies at various capacities at the University Visvesvaraya Technological, University Belgaum. So with this brief introduction, I welcome you, sir, once again for this webinar series on behalf of mechanical engineering.
Thank you. Thank you.
Thank you, sir. We have with us today Dr. Satish Kumar, HOD Mechanical Engineering. He took the initiation in organizing this program, along with his all the deans, all the heads department faculties. Apart from that, all the registrants who are present today, for all of them, it is my duty to welcome all of you. Thank you, one and all. Thank you, sir.
Thank you, sir. Thank you so much for your welcome and introduction of the chief guest.
Yeah.
Now I request our beloved principal, Dr. Mohan Babu GN sir, for his opening remark on this webinar of the global career prospects. Over to you, sir.
Yeah, thank you, Dr. Govindraju, Dr. Satish, and Dr. Sangamesh. Good morning to you all. Elrigu namaskara. Welcome to BMS Institute of Technology and Management, Bangalore. And also welcome to the webinar series on the profile of various engineering programs, engineering streams. A very special welcome to Dr. Ramesh Singh from Malaysia. I'm so glad that he has been able to make his time for us, and also for the great social cause the BMSIT is putting its efforts towards. We are organizing this webinar series for the 12th standard or PUC qualified students who are aspiring to pursue bachelor's degree in engineering education, but finding it very difficult to make a right choice of the stream of study. The purpose is this. Having been in the educational field, especially teaching, research, administration of the technical education in India for about more than three and a half decades, I have noticed that a significant proportion of students in India who are aspiring to pursue higher education, not necessarily technical education, any higher education for that matter, often make an incorrect choice of the stream of education. Due to this may be for various reasons. This may be for various reasons. One is their inability to identify the passion in life at the right time. That's the most important thing. Second thing is their inability to collect right information, adequate amount of information, and timely information about various kinds of higher educational opportunities. And third one is hasty in making decisions, and most important of all of them is their susceptibility to the influences of people around him or her. Maybe parents, maybe society, maybe sometimes teachers or whoever it is, right? That's how it is. And this incorrect decision, once made, locks him or her up in that particular stream for some time. At least for 1 year, they will not have a choice. Second year, they might have a choice, especially in engineering, they might have a choice, but not sure that they will be able to change the branch. Now, because of this incorrect decision, it so happens that they will be unable to fulfill their life's dreams. They will not be able to enjoy the quality of life they look forward to. They will not be able to develop themselves to their fullest potential, which they have. Not only this, it also drains out the resources of parents and resources of the institutions to which they join, and government and the society at large also. In fact, everybody, it's a lose-lose situation for everybody. All these are true even with technical education programs. In fact, even in engineering, are those people who wish to join engineering, we see this kind of a situation. Hence, at BMSIT, we felt that we need to engage in this kind of a social responsibility to help these kinds of students who are the aspirants of engineering program. We do it for engineering because we are in this particular profession. We wanted to help them to make a right choice of the stream of engineering education for themselves. As a part of the social responsibility, we planned at BMSIT this webinar series to expose and enlighten students to various streams of engineering, highlighting the importance of each of these streams in the development of or in building a nation, and the kind of technological advances that are happening over there, the developments in research happening there, innovations, technological innovations coming up, job prospects, career opportunities, maybe, okay, they could even choose the entrepreneurship. What is the scope for entrepreneurship in that area? And opportunity for higher studies and all such things, over or whatever our children are interested in knowing. And we wanted to offer this information and knowledge from the experienced professionals, both professors and researchers in this field, both from India and abroad. That's what I'm saying. We have very senior professors from reputed institutes, both from India and abroad, who will speak to you on various streams of engineering education as per this schedule that has already been shared with you. I'm sure that such a global exposure to various streams will help you to make a right choice for your higher studies, because that will be in the backdrop of global scenario of that education that you're looking for. We hope that our efforts will make an invaluable difference in your lives. And I would say that we wanted to choose this, or rather we had to resort to this online platform, keeping in view the conditions prevailing due to COVID-19 pandemic. Let me congratulate all my colleagues at BMSITM for their groundwork that they have put in order to organize this webinar for 6 continuous days and 8 streams, and also the information technology team that we have here who have onboarded you for this webinar series. I thank all the professors, both from India and abroad, who have consented to partner with us, with BMSIT, to address this important social cause. Hope all these participants will have all of you will have a very great takeaway from this webinar series. All the best for your future. Thank you very much. Thank you. Please go ahead.
Thank you, sir. Thank you for your thank you for the opening remark and inaugural address for the today's webinar. Now I request Professor Dr. Ramesh Singh sir to address the students and all the delegates. Over to you, sir.
Okay, thank you. Good morning, all. Foremost, I would like to say thank you to the principal, Dr. Mohan Babu, for inviting me to give a short speech about mechanical engineering. And also the vice principal, Dr. Govinda Raju, for extending the invitation. It's my pleasure to be here to share with you why aspiring students should consider mechanical engineering. I'm sure over the week you would hear presentation from other colleagues, other professors and professionals about the other fields. But this morning, let me talk about mechanical engineering. I have a presentation here that I want to share. And there will be some videos that I would play, and I hope that there will be no any interruption to the connection. Okay, let me just share the presentation first. Huh? Okay, I hope you can see the presentation.
Yeah, yes, Professor.
Yes, sir.
Okay, right. Okay, because I'm not sure with Google Meet, with the other platform, normally they will show that the screen is sharing, but okay, great. All right, my talk today will be mechanical engineering, a highly lucrative and intrinsically rewarding career. My name is Ramesh. I'm with the University of Malaya. Currently, I'm on secondment at the University of Technology, Brunei, as a senior professor. So just a brief biography about myself. Dr. Govinda Raju has already given a short presentation. So this just a summary. I'm actually a mechanical engineer. I graduated with a first class honors in 1994, and subsequently I went on to do a PhD in advanced ceramics. These materials are used basically for mechanical application. I have about 25 years of consulting, research, and tertiary education. Currently, I'm a senior professor at the University of Malaya in the field of mechanical and materials engineering. I've served as associate director with the Engineering Accreditation Department, Board of Engineers Malaysia for 4 years. So basically, I'm quite well versed with accreditation requirement. I published a lot of papers, about 350 over scientific papers, completed 32 PhD, about 75 postgraduate. I'm also visiting professor in several universities around the world, received a lot of awards. In terms of funding for research, I've attracted about $5 million for funding. I'm also a fellow of the Academy of Sciences Malaysia and fellow of other prominent professional societies like the Institute of Mechanical Engineers, Institute of Engineers Australia. I'm a registered chartered engineer with the Engineering Council, chartered professional with the Australia body as well, with Engineers Australia and in Malaysia. And basically, if you look at my research interest, it's quite diversified. And I must say that because of my training in mechanical engineering. So this is one of the advantages, I would say the main advantage actually, to take up mechanical engineering. All right, just a brief background about University of Malaya. So it's an old university. It's 115 years now. Started in 1905, and then it went on, started in Singapore, and subsequently after independence in 1957, then the two universities actually split. So we retained the name University of Malaya in Kuala Lumpur, and NUS, National University Singapore, and University of Malaya, both are brothers and sisters. Okay, so both in terms of years, 150. So it's quite a old traditional university. We have a lot of programs, more than 200 academic programs. We have 3,500 international students. Total students population, about 27,000. Comprehensive university, 13 faculties. We have 4 research cluster, more than 50 research centers, and so on. In terms of academic staff, total staff 6,000, but academic is about 2,500 academic staff, and the rest they are supporting staff, research staff, administration, and so on. And out of these 2,500 academic staff, we have about 250 to 300 international academics, and they come from more than 40 countries around the world. This is part of the strategy for ranking. We try to maintain about 10% or more international academic staff. In terms of ranking, University of Malaya currently is ranked 59 in the world. This is the latest ranking. In Asia, we are ranked 13. So we are quite highly ranked in as far as academic and research is concerned. All right, so for more information about University of Malaya, you can visit the website, and we welcome anyone who wants to collaborate with the university. Okay, now I know I'll be addressing academics as well as students, but because the series are meant to be addressed to potential students. All right, so let's look at the marvels of mechanical engineering. You know, as the Dr. Mohan Babu mentioned about choosing the right career and later on regretting and I'm not sure what to do in life and so on. Well, I think most important, I think this seminar is timely because it gives the opportunity for people like us to address parents and potential students on what they are getting into, you know. So when we look at mechanical engineering in the nutshell, it's all about designing, constructing, and using machines. Okay, it is almost impossible to imagine aspects of our daily life without any influence of mechanical engineering. If you look around you, any machines, obviously they are not built by lawyers or medical doctors. They are definitely built by mechanical engineers. Okay, if you look at even small water taps in our homes to complex machine, you can always see the principle of mechanical engineering, and that's what I will touch a little bit as we go along. So each mechanical device is a wonder in itself, utilizing the principles of force, motion, energy to make our life easy. If you think about it, we actually use energy to do work, all right? And from there, we are able to do so many things. We are able to make things happen. Now, when we look at a simple lawn mower to a motorized lawn mower, who do you think developed this? Who do you think built this? The lawyers? The businessman? Obviously not, isn't it? There's a lot of engineering principles that we need to consider, whether it's just a simple lawn mower where it does not have any machines, but the mechanism involved. It's all mechanical engineering. If you look at our daily life, we cannot live without air conditioning. You know, how do you think these are being built and being used in our everyday life? Refrigerator, the same principle. If you look at the principle behind it, the refrigeration principles, that's what we learn in mechanical engineering. Likewise, air conditioning principles. The other thing that we can always see is power generation. If we look at a typical nuclear power station, right? If you look at the components, we have a steam turbine. So as the name implies, we use steam, all right? We use steam to do work. As the steam rotates the impeller in the turbine, it is connected to a generator, and that's how electricity is being generated. And we have to think about how to keep the system going, because when we look at power generation, it's 24/7. We don't store electricity. You know, it's being supplied continuously. All right, and these are wonders of mechanical engineering. So we need to develop components that can treat steam back into liquid and then back into steam again. All right, and that's where we have the sources like nuclear or coal being used to supply energy to heat up water, convert it into steam, bring the steam up to a certain pressure, and then drives the turbine. You know, and that's how the cycle goes. All right, so typical nuclear power station, you need mechanical engineering principle, or you may have a coal fired. So the fuel used to actually convert liquid or water into steam may be different, but the principles are the same. We still have a turbine, we still have a generator, all right? And we have pumps, and we have compressors, and we have boilers. So these are basic components that mechanical engineers design. Okay, besides power station, if we look at cranes, tower cranes for construction, or even the excavator. Now, all these are mechanical. They are hydraulics, they are pumps, you know, they are machines. All right, and this is where mechanical engineers would participate and would design them and make sure that they can function as they are required. This is another marvels of mechanical engineering, the aircraft carrier. This is one of the biggest, USS George H.W. Bush. This carrier, it's very huge. It's constructed or commissioned in 2009 with a total cost of $6 billion. Okay, it carries 2 nuclear reactors, which can fuel the aircraft carrier for for more than 20 years, okay, without needing any refueling. All right, so 1,000 feet, the flight deck with 76 over meters wide and 300 meters long. So this if you are familiar with the 100-meter run, that's 3 times of the 100-meter. That's the length of the carrier, right? And carry 6,000 crew members and accommodate more than 60 aircraft. Now, all this could not be possible without mechanical engineering. All right, this is another wonder, the NASA solar probe, which are being developed and used to study the sun. You know, and it took 8 years to actually build this solar probe. All right, and you know, the temperature of the sun is very high, and the probe will need to sustain such high temperature. And this requires knowledge in materials, and it requires knowledge in how to communicate, all right, what's happening up there with the engineers on the ground. All right, so this has been developed about 10 years ago, and it costs about 1.5 billion. Now I have a short video I want to share on this solar probe. It's only about 2 to 3 minutes, so that you can see what are the components and what are the challenges the engineers will have to go through in order to build this probe. Okay, so just let me share the video. Can you all see this?
NASA's Parker
Yes,
solar
sir.
probe
We can.
explore the sun. How can it do that? Why won't the spacecraft melt? Excellent questions. You can't face off with the sun without packing the right gear. This is why Solar Probe is equipped with a white shield that reflects heat off the front and keeps things cool at the back.
The heat shield is made out of a couple of different materials. One is carbon-carbon, which is a lot like the graphite epoxy you might see in your golf clubs or your tennis racket, but it's just been superheated. The inside is a carbon foam, which is just another form of carbon and is actually about 97% air. It's a very lightweight way of making a very strong structure.
Nobody likes a needy explorer. Solar Probe can take care of itself, thank you very much. And that's because it has autonomy software that will keep its instruments safe and cool behind the heat shield.
We're too far away to joystick it into place, so it basically has to always be sensing whether or not the heat shield is in the right position and correct itself if it isn't. There are these things called solar limb sensors that are just poking out at the very edge of the shadow, and if those get illuminated, the spacecraft knows, oh, I'm going the wrong direction, and can actually right itself.
It's important to stay hydrated in the sun, even for a spacecraft. Solar Probe circulates water to keep the solar cells from overheating. It stays cool and keeps power.
So basically, water flows behind the solar rays and into the radiators, and so the water warms up when it's behind the solar cells, and then cools down up at the radiators, and so that heat transfer is happening a lot like the veins in your body.
Yes, you read right. Heat is not the same as temperature. Temperature is a measurement, but heat is energy transfer. This matters because Solar Probe will be visiting the sun's outer layer, the corona. Like all stars, the sun is made of plasma. How tightly packed that plasma is depends on the layer. While the sun's corona has a very high temperature, the plasma particles are fairly spread out. So even though the temperature in the corona is 2 to 3 million degrees Fahrenheit, the heat around the spacecraft is manageable.
The corona and where we're going is actually not that dense at all. There are only a couple particles. And so when we think about it, those are very hot, but we're not touching a lot of them. It's the kind of like when you put your hand into an oven, and the oven might be at 400 or 500 degrees Fahrenheit, but your hand isn't at 400 or 500 degrees Fahrenheit.
Thanks to its design and destination, this cool, confident spacecraft is all set to explore. We can just sit back and chill as Parker's Solar Probe takes the heat.
Okay, yeah. So we have seen a short video, and you can see there's a lot of heat transfer. There's cooling system to be considered, and this is where mechanical engineering comes in play. Yeah, another one that I want to share is the world's largest dump truck. Now, basically these truck, they are designed by mechanical engineers, basically to help the construction. All right, and this dump truck is basically to carry away all the rubbles that is being dumped up and so on. And this is the one of the largest dump truck ever developed in the world, and it's weighed more than 800 over tons. The vehicle itself is about 360 tons, and it can carry a load of 450 tons. Okay, so to achieve these, the giant dump truck consists of 8 pairs of wheels, each wheels capable of carrying 100 tons. Now, there's a lot of load on each wheel. And this is where, the engineers will have to look at how to ensure that the design of the axle and the material that they use are able to sustain such high loading. And whenever there's a transverse load, there will always be shear effect as well. And so the mechanical engineers will have to look at all aspects. And that's what we learn, in mechanical engineering. And I have a video on this as well, so that you guys can appreciate. So let me just play the video on the dump truck. A short video, about 2 minutes.
We will produce a mining dump truck that will carry a minimum of 450 tons of mined rock. An entirely new class of mining dump trucks, developed by the LAS.
No, not visible.
Original rotational
Not visible, sir.
Video not playing, sir. Ramesh.
Solutions in steering gear. Solutions in the load carrying frame. Two diesel generators, 4-wheel electric motors, 8 tires, 4,600 horsepower. When the truck carries the load, it happens.
Dr. Ramesh?
When the truck rides to get a load.
Sir, can you hear us, sir?
This means that we save on fuel.
Professor Ramesh Singh, sir?
The truck can drive on the same roads as a 360-ton truck. It fits into the same dimensions of the repair bay. Any driver who has the license to drive mining dump trucks may drive the 450-ton truck. The algorithm of the driving is exactly the same.
Today, these trucks are already assembled at new production sites, specially built by Balas.
In 2012, in Las Vegas, the creation of a 450-ton capacity truck was announced. You believe, year has passed, and here it is.
Overcoming slopes up to
Dr. Ramesh?
all-wheel drive. A maximum speed of 64 kilometers per hour. Design capacity is 25% higher than all existing mining dump trucks of the highest capacity.
This truck will make a great claim about itself.
Balas 75710.
This will be a good mining dump truck.
Ramesh, sir?
Yeah.
Sir, can you just once again, can you present the video, sir? Because it is not...
Okay. Let me just... Can you see it now?
Yes, sir.
Okay.
We will produce a mining dump truck that will carry a minimum of 450 tons of mined rock. An entirely new class of mining dump trucks, developed by the LAS.
Maneuverability. Original rotational kinematics.
New solutions in power drive, solutions in steering gear, solutions in the load carrying frame.
2 diesel generators, 4-wheel electric motors, 8 tires, 4,600 horsepower.
When the truck carries the load, it has 2 engines working. When the truck rides to get a load, only 1 engine is running. This means that we save on fuel. The truck can drive on the same roads as a 360-ton truck. It fits into the same dimensions of the repair bay. Any driver who has the license to drive mining dump trucks may drive the 450-ton truck. The algorithm of the driving is exactly the same.
Today, these trucks are already assembled at new production sites, specially built by Balaz.
In 2012, in Las Vegas, the creation of a 450-ton capacity truck was announced. You believe. Year has passed, and here it is.
Overcoming slopes up to 18% all-wheel drive. A maximum speed of 64 kilometers per hour. Design capacity is 25% higher than all existing mining dump trucks of the highest capacity.
This truck will make a great claim about itself.
Balaz 75710.
This will be a good mining dump truck.
Okay. All right. So I hope, if you look at this dump truck, there's a lot of mechanical engineering stuff that goes in there. It's complex, as mentioned by our principal just now, that we need to teach our students to solve complex engineering problem. And if you look at the drive and the fuel consumption that they have to consider, bearing in mind you are looking at more than 700 tons of weight when it is fully loaded to be moved, and yet you want the machine to be fuel efficient. And this is where mechanical engineering, comes in, and we have to consider sustainable development as well. We have to think about, a machine that is most efficient and use the least fuel. Okay, other application in materials development for biomedical application, that's what I'm involved in. I will talk a little bit about that later on. When people break their bones, for example, you need to use metal implants. These are metallic implants, either titanium or stainless steel. Or if you have a fracture hip, for example, in the Europe, very high percentage of people as they age, because of obesity, they are heavyweight, they break their hips, and for that they need to have a hip implant. And basically the hip implant, you have the femur bone and you have the pelvic, and what really happens here is that you need to have a stem, which is normally made out of metallic, can be titanium or stainless steel, and in combination with polymeric cup and ceramic head. Okay, and this part, the acetabular shell, goes into the pelvic, and this helps patient to have mobility, and they are able to stand and walk again. All right. In the dental application, as we age, we really need to take care of our tooth. Once we lose our tooth, for the tooth to grow back, I think it's almost impossible, and therefore we have to put an artificial implant. And for that, we have to depend on materials that are able to be accepted by our body, and that's where we have ceramic implant, we have metallic implant as well. Another good example where, in countries like in India and in Malaysia as well, we have a lot of people that rides motorcycles, and they get involved in accidents, and as a result, they might injure their leg, and they might break their bones. So for carcineal fracture, for example, you have multiple, your section breaks into multiple component, and you need to hold them together, and that's where we use metallic plates. These are titanium plates and screws to hold the bone together to allow healing to take place. All right, and you must understand that as we age, the healing process, the bone is very slow, and that's why we need to take care as we age. When we are young, our body heals fast, but as we age, healing is slow, and for that we have to rely on engineering materials, okay, to support or to help with the healing process. Okay, this is another marvel of mechanical engineering, is the tunnel boring machine, or short form TBM. If you think about underground tunnels, railway, rail, metro station, metros, run underground, and do you ever wonder how this is being done? How they actually make the hole in the tunnel. Yes, some may say that it is civil engineers, it's involved earth, so it's civil engineers that actually do it. But if you really look at what being used in order to make the tunnel, it's mechanical engineering. Without this TBM, there will be no tunnel. And it is mechanical engineers who actually think about the boring machine and how this can actually be used. And bear in mind, we are looking at a diameter of 40 meters wide, for example. If you look at in relation to human standing next to it, right? This is a very large cutter, all right, and it cuts through soil and earth. All right, and I've got a video to show you so that you can appreciate what mechanical engineers have done in terms of developing and designing this TBM. Okay, so let me share another short video on TBM. Can you see this video?
Yes, sir.
Okay.
Sir, I'm afraid I can't see the video. The screen is entirely white. Could you
can't see the
replay?
video?
Hello, we are not able to see the video, please.
Sir,
Okay.
can you share the presentation?
Okay, let me. You can't see the video just now?
We can see your screen now.
Now we can see, sir. Now we can see.
Okay, let me play the video again. Huh? Can you see the video?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, we can.
It's gone again.
Sir, it's gone again, sir. We can't see.
So actually, somebody is interrupting sharing something.
Yeah, somebody else is also trying to share screen. So that's the reason this is
He's
happening.
not able to. So,
You can't see it again?
No, sir.
Okay, just 1 second.
And now we can, sir.
Okay, let me play the video again and see if you can see the video. Can you see it?
Yes, sir. We can.
Okay, so that's the TBM. All right, and if you look at the system, there's hydraulic system, and the mechanical engineers have to think about as they dig up the soil, how they're going to transport the soil out. So what they do is they have to crush it within the machine, and they have to make it into slurry and transport it all the way back to remove the remove the dirt. All right, and you can see they use hydraulics, and while the tunnel is being bought, they actually lay the wall, so that they don't have the back section that they have dug up collapsing and so on. So there's a lot of thought that needs to be put into the process on how this thing works. I want to show another machine that is currently being used in India, in Mumbai, to build your metro station, which will complete sometime in 2022. So I have another video. This is what's happening now in Mumbai. Can you see the video?
Yes, sir. Yes, sir. We can see.
So this is a mega project, metro project in Mumbai.
So how much energy it consumes per second?
Okay. Right, so that's the TBM, right? So of course, mechanical engineers work hand in hand with civil and with electrical, electronics as well, because there are communication aspect that needs to be considered, and that's where we rely on our other colleagues in order to think about the sensors and how to track the trains as the train is in motion and so on. So, but you know, if you look at the video just now, the assembling of the TBM, you could clearly see all the components being put in, and certainly they are all mechanical based. And this is where you know, TBM is one of the marvels of mechanical engineering. I mean, that's how we you know, help to make people's life better by, you know, helping with the development of tunnels, metros, and so on. Okay, it is when we talk about mechanical engineering, it's the oldest and broadest branch of engineering. It's a discipline of engineering that applies the principles of physics. You cannot run away from physics and material science for the analysis, design, manufacturing, and even for maintenance. At the design stage, as mechanical engineers, we think about the maintenance aspect, ease of maintenance. You know, we have to inbuild maintainability within the design. We cannot wait until the components are built, then we think about maintenance. Okay, so it involves production, usage of heat, mechanical power to do work, such as in power generation, water purification, operation of machines for production, agriculture, transport, infrastructure, and so on. Whenever there's machine, there's mechanical engineering. You know, you cannot run away from that. Now, when we look at the mechanical engineering knowledge profile, as you see in all those videos, there's a lot of principles and concepts that we need to know: kinematics to heat transfer to thermodynamics to cooling system. And that's where we will learn how to analyze systems. So you will learn statics, dynamics, fluid mechanics. You understand fluids behavior, what are the relevant equations, you know, how can you model a certain behavior through maths, and so on. You study about engineering materials. You know, you can have the best and the design that you can ever think of, but if you don't put the right material, your design will fail. All right, so the limitation in any design lies in selecting the right material. If you choose the wrong material, you know, as I said, although your structure may be able to sustain load, but your materials are not able to sustain the stresses. There's a lot of thermodynamics and heat transfer. Because we have knowledge in heat transfer, we are able to build a heat shield. We understand how to protect the instruments from overheating and melting, right? Because we understand how heat is transmitted. A lot of design, we will do design, instrumentation and control. We will learn about this, but not in very detail, because we, as mechanical engineers, you need to understand a little bit about instrumentation and control as well. Vibration is a core in mechanical engineering. Any machines that we deal with, there will be vibration, and we must dam the vibration. If not, the biggest issue with vibration is that when the materials vibrate at its natural frequency, it breaks. And therefore, in any design, when there's vibration, we need to take care of vibration. We need to ensure that the vibration does not reach to the natural frequency of the material. If not, disaster takes place. You will learn about solid mechanics. You will look at manufacturing. You will look at production, electrical power and machines. Although we are mechanical engineers, we still need to understand about electrical power. Like, for example, a generator, a transformer. What's the principle, how it works, how these devices actually generate electricity. So we need to understand that, all right? Electronics and microprocessors, so we will learn, we are exposed to these as well. And of course, a lot of simulation, computer-aided engineering. So these are generally core concepts that you will learn in mechanical engineering, okay? You will also learn about computer-aided design and manufacturing, economic analysis, information systems, a little bit of operational research, you cannot run away from project management and finance, because at the end of the day, as we move up the ladder, we go into managerial positions. And as project managers, we need to know how to manage project, right? And we will deal with finance. If not, then we have the accountants who will try to teach us how to, spend the money in the project and so on. So that's where, as mechanical engineers, we must know about finance as well. And of course, ethics. As engineers, we have duty to society, and therefore ethics is very important. All right, and we as engineers, we have to understand that we are governed by law, and we need to protect the society as we build devices and machines, right? So ethics is something that we cannot run away from, and of course, finite element analysis. This is to help us to understand behavior of structure before it's being built. So we can actually make simulation, right, and analyze how forces would be transmitted, which area would be more critical, and we need to take care of the critical areas and so on. So this is where FEA CFD, it helps us with simulation, okay, before actually building the structure or the component. And of course, we also study a variety of specialized elective topics, okay, all depending on expertise available in the university. But generally, these are core principles that you will learn, all right? Because as you can see, all the examples that we have gone through, it all deals with energy, heat, kinematics, statics, a lot of forces, a lot of stresses. There are materials involved. So if you really look, these are the core that you will have to learn in order to help you to design anything that you want. Okay, and of course, in today's world, we cannot run away with the advancement in technology, right? And that's where we have this revolution 4.0 and 5.0, the IoTs, Internet of Things, use of sensors, touch screen, and so on. So these will be incorporated in the design. So in the university, students would be exposed to such technology, or you will be exposed to the knowledge of this technology so that you can apply them. All right, you can apply this technology. I think what is important is how to use this technology to assist in our design, and you will look at various fields like robotics, mechatronics, even bioengineering, nanotechnology, and so on. So much so today, if you look at mechanical engineering, it overlaps with other fields as well, with aerospace, with building services, with metallurgical engineering, medicine, biomedical engineering, marine, civil, and structure, as you can see just now for the tunnel boring machine. I mean, we work hand in hand with civil engineers. Obviously, we don't know the soil condition. It's civil engineers who decide where should we bore, and that's when we put our boring machine and we bore the hole, right? So we work hand in hand with civil and structural engineers. You have a lot of electrical engineers as well, electronics, petroleum manufacturing, and so on. So if you see, the field is quite diversified, and it overlaps with other branches of engineering. So in a nutshell, I would say that mechanical engineering, I mean, this is my take. It nurtures people, you and me. It gives us that strong analytical thinkers. We become very, what I would say, in detail in looking at solution. All right, so we are able to think. We are able to decide how can we apply engineering knowledge, and what should we put in place in order to make life better. All right, so we can solve complex engineering problem and undertake complex engineering activities. I mean, you've seen all the examples shown just now. It's complex. I mean, the machines involved are complex. The tasks involved are complex, right? You have to think about how you're going to deal with situation. Like in the tunnel boring machine, how are you going to get the dirt out? And how are you going to actually place the wall? Now, all this, you don't expect the electrical engineers to think about, right? You don't expect biomedical engineers to come up with an idea how the wall is going to be built. That's where mechanical engineers are pushed to the limit, right? So we don't just look at a small picture of the design, we look at the total picture as well. All right, and that's where we become analytical thinkers. sometimes my wife would say that I think too much. Even to make up, to make a decision on small items, I would think about, how long it will last. I would look at the cost. I would look at the break-even analysis. Is it worth it to spend so much of money? So we think too much. But that's good, because especially in design, that's what we need. We need engineers to really think about the whole picture. So in terms of engineering application, emphasis on engineering application in mechanical engineering degree programs aims to ensure that all graduates have a sound understanding of up-to-date industrial practice. So in particular, you must appreciate behavior of materials, in a variety of loading and environmental conditions. For example, composites, right? People talk about using composites material for design. If you look at a Ferrari, for example, the body are made out of composite. But do we actually want to use composite for every design, right? So that's where we have to think about whether or not it's justifiable to use a very strong material in a small design, right? And we have to understand the behavior of those materials, right? And if we understand the environmental condition like corrosion behavior, if let's say the environment is corrosive, right, we have to think about using metallic material. Metallic material will corrode eventually. So how can we protect the metallic material from corrosion, right? So you can use coating. Today we even use ceramic coating over metallic implant, metallic component, all right? And just like in biomedical, we use metallic, but we use a ceramic coating over the metallic body. And this ceramic can be engineered to be biocompatible, where our body can accept the ceramic material. All right, I will talk a little bit about that in a while. We will look at a range of manufacturing systems, energy requirements, and what are the skills required, okay, to serve the wide-ranging industry. We appreciate cost aspect, as I mentioned, right? We need to think about cost. As I said, no point using composite material to make a small component, and it's going to cost a lot because of the manufacturing process that we need to go through, right? So it's going to cost a lot, and consumer will not pay for it. So we need to ensure that we have a good design. At the same time, it must be cost effective, all right? So that consumers are willing, able to buy and use those components. We need to understand the process involved in making the resources and sustainable development. In today's world, it's very important to look at sustainable development as well, because mechanical engineers, we build things, all right? So we build things to make people's life better and healthier. But we also are to be blamed to build systems that can cause destruction. And that's where sustainable development comes in. All right, we need to incorporate sustainable development principles in our design, and that's where we learn about eco-design as well. Okay, eco-design looks at the incorporation of the 3 pillars of sustainable development. All right, and you will learn this in your course when you take up mechanical engineering or perhaps any other engineering as well. Okay, and in terms of function, the sky is the limit, as you see in all the videos. Mechanical engineers, they are in unique position to undertake a wide spectrum of function, both technical and non-technical. All right, so some of the prominent function, you find where mechanical engineers are engaged in R&D, in design, in testing and quality control, failure investigation. That's what I do. When components fail, we need to understand why failure takes place, and that's where mechanical engineers with materials knowledge comes in. We look at manufacturing technology, operation and management. Even we also can do marketing and sales, administration and management. Now, all this possible because of the unique the education that we receive in mechanical engineering. You learn about all sorts of theory, and you can apply them to both technical and non-technical. You also learn project management, you learn finance, and that's where I have some of my friends, after their degree, they actually pursue MBA in finance, and they work in the bank. You know, so they don't really take up engineering job, but they take up different fields, and this is possible with mechanical engineering. All right, so these are areas where industry, where you frequently find a lot of mechanical engineers engaged in automotive, machineries, industry machineries and automation, power generation and utilities, chemical plant, computers, technology, manufacturing, production, mining, agriculture, dairy production, oil and gas, petroleum engineering. Okay, and they also into other areas, textile, printing, wood industry, right? If you think about wood industry, if you think about furnitures, you know, you design furnitures and so on. So who do you think decide how large a particular furniture should be, or what would be the support? Can we design a furniture with just 3 legs or with 2 legs, for example? So who do you think put the thoughts into the design? It's the mechanical engineers, right? So mechanical engineers plays a very wide-ranging role in coming up with solutions for the industry and for the people. All right, we find mechanical engineers work in the government sector, in private sector, in consulting engineering firms, you know, providing consulting services, R&D. Some of us actually ended up in colleges. You know, we become lecturers and we teach engineering. Now, when we look at the degrees in mechanical engineering, nowadays we have many colleges and universities worldwide. They offer the program, mechanical engineering program. Now, typically, if you are aspiring to take up mechanical engineering, the Bachelor of Engineering BEng, or sometimes it's also called Bachelor of Technology BTech, typically 4-5 years. 4 years is normal, right? 5 years is the European model. In Europe, like in Germany, for example, the degree is basically span over 5 years. They spend 1 year in industry. But other parts of the world, they probably do 4 years. Some program, they have 3 years program. But typically, we are looking at 4 to 5 years, okay, to complete. And of course, some of you may want to do a diploma first, and before you decide to do a degree. Like myself, I did a diploma. I did a diploma because I wasn't sure initially whether I wanted to do a degree. And so I took up a diploma, and a diploma typically takes about 2.5 to 3 years. But of course, if you are eligible directly after your A levels, for example, you can do a degree. This would be the best option, all right? You immediately go into a degree program and you start your studies. And once you have a degree in mechanical engineering, you can actually branch out. You know, you are not confined to stay in mechanical engineering. As I said, sky is the limit. You can then pursue a master's. In the master's, you can decide to take up engineering in a different area or related area. So, for example, you may have done a BEng in mechanical engineering. You may want to take a MEng in production engineering or in metallurgy engineering. So it's related. Or even in control engineering, or sometimes you can take up a Master's of Science in related fields. In order to also do MBA, once you have a degree in mechanical engineering, you can also take up MBA. And normally for MBA, they requires the candidate to at least have 1 year working experience. So maybe you might work in the industry for 1 year, and you realize that you need some management knowledge, and you may want to take up MBA or Masters of Arts or MA. Now, some of us would have that passion that we want to go further. We would then take up doctorates, PhD, Doctor of Science, right? Either PhD or Doctor of Science in related field. Taking up a doctorate, you would focus on a very small area and you go very deep, all right? And you become an expert in the field, all right? You study about phenomenon, you study about behavior, you try to understand and try to come up with new ideas or new knowledge. Okay, you develop new theories and so on, and that's what people do in doctorates. All right, and if you planning to do a master's, typically takes 1 to 2 years. You can do it in India, or you can do it anywhere else outside of India, or you can also pursue a PhD. Nowadays there's a lot of scholarships available for people, international students, from countries like Japan, even Europe, and the US as well. But of course, this pandemic, this is a little bit of a setback. The pandemic has taken a toll in many countries, but I'm very sure if within in a year or 2 years time, things would be recovered to normal, right? And you will have that opportunity eventually. I mean, to pursue masters and PhD overseas. But certainly in India, you have very good colleges and university like, for example, BMSIT. So these are prominent colleges with years of experience producing graduates, and a lot of their graduates are already in industry, so they have proven track record, and you would definitely get a very good mechanical engineering education from BMSIT. I'm very sure of that. Now, when we talk about recognition, as mentioned just now by the principal and as vice principal, the programs are offered in the institute. They are actually being accredited, and that's very important because of global recognition, right? So for engineering per se, we have this thing called the Washington Accord, all right? And India, through the National Board of Accreditation, okay, NBA, and of course Malaysia, through the Board of Engineers Malaysia, we are signatories in the Washington Accord. So what it means, I mean, we are part of this International Engineering Alliance, IEA, right? So what it simply means is that the degree offered by the institution in India and in Malaysia, they are recognized worldwide, okay, because we govern by certain standards. So they are global recognition. All right, so this just the IEA. I just highlight this section here, right? So by having this Washington Accord, our degrees are recognized, and we can cross border, and we can serve, and we can take up projects in other countries. Okay, this is the latest list. As you can see, Malaysia is there, and India, okay, represented by the National Board of Accreditation. And how all the signatories, there are about 21 signatories in Washington Accord as of today. Now, all these 21 signatories, they have different systems put in place as far as education is concerned. But what is important is that they must meet the substantial equivalence. Okay, what it means is that while not meeting a single set of criteria, right? Like for example, in India and in Malaysia, we have different sets of requirement based on the country requirement, but both are acceptable because we meet the substantial equivalence. That is, we produce graduates that meet the knowledge profile. All right, so there is certain knowledge profile that the program must comply to, right? Like just now I mentioned all the core areas that for mechanical engineering we must have. As long as that has been covered, then we have met the substantial equivalence and so on. And there are other requirements which the university and the institute would consider when they develop the curriculum. All right, these are the knowledge profile. Typically, engineering students would have to demonstrate these 12 graduate attributes, right? You must have engineering knowledge, you must have problem analysis skill, you must be able to undertake design and development of solution, carry out investigation, able to engage with modern tools, you understand ethics. This is where engineers and society comes in. Sustainability, right? Environment and sustainability. We have ethics, we have teamwork. In the program, you will learn to work individually as well as in a team. You need to build communication. This is one area where engineers are very much lacking, and that's where programs would, inculcate a lot of communication. So you will have projects, and you have to make presentations and so on. You will also develop project management and finance skill, and of course lifelong learning, right? And that's where the program instill lifelong learning in the students, so that you never stop learning, right? So when you graduate, the learning continues. All right, and eventually you would pursue professional recognition. This is what I tell my students. I used to be the head of mechanical engineering department at the University of Malaya, and every semester I would meet all the year student. And part of my motivation talk, I normally give motivation talk, and also to remind students that basically our aim, our program aim to produce professional engineers. So eventually we want to see our graduates becoming professional. All right, and this is where if you take up engineering, it should be clear in your mind. Ultimately, you want to pursue professional. You want to become a professional engineer or chartered engineer or chartered professional engineer, because these are notable profession. I mean, you stand out in society. Becoming a professional or chartered engineer simply means that you have attained that necessary practical as well as theory knowledge. So you are knowledgeable as well as you are able to apply this knowledge in solving engineering problems. And that's why people pursue the professional status. All right. And there are bodies that gives this professional status. You will be evaluated eventually, like Engineering Council, Engineers Canada, and Engineers Australia. So I have, for example, I have the professional qualification from all these three international bodies and from the local bodies. All right. So when we talk about mechanical professional bodies, of course, the Institute of Mechanical Engineers UK. This institute is the oldest. Formed in 1847. Right, so it's one of the oldest institution, and of course in America we have the American Society of Mechanical Engineers, ASME. This quite old as well, in the 1880. And in India you have the Institution of Mechanical Engineers, established in 1914. All right, so eventually you can be part of this professional society. And why being part of this professional society is important? Because this is where it provides the platform for networking. You get to meet, fellow mechanical engineers. As part of lifelong learning, you are able to participate in their activities. You are able to, provide services to society and so on and so forth, right? So you belong to a professional society, all right? And that's why eventually we would pursue professional status. All right, so of course, mechanical engineers have a lot of prospects in R&D. A lot of our graduates actually pursue research as their career, and they venture into diverse areas, including nanotechnology, development of new devices, efficient machines, novel materials, and so on. All right, and if you look at the medical field, right, mechanical engineers has basically revolutionized the field of medicine, right? You develop new materials, and these materials are called biomaterials or bioceramics. And that's where people like me, I have a mechanical engineering degree. Eventually I develop biomaterials and bioceramics because I understand how this material behave in the body environment. These materials must be able to sustain loading, right? And we apply the theory that we learn in mechanics: stress, strain, forces, engineering materials, heat transfer, fluid mechanics. When we talk about fluids, blood flow, right? So there's fluid mechanics and so on. So that's where mechanical engineers are able to venture into the medical field. All right, so I'm going to talk a little bit about the area that my expertise are in. That is in the processing of bioceramics. So we use microwave technology. I will cover two main material. I won't bore you with the theory. Very quickly, we look at the wonders of this material, how they are actually being developed and used for clinical application. All right, so let's look at hydroxyapatite and tetragonal zirconia. Now, when we look at hydroxyapatite, short form, I call it HA, right? Hydroxyapatite, they are calcium phosphate based material. So they have excellent biocompatibility, all right? Because its constituent, if you look at the material, it is just calcium and phosphorus. And that's what our heart tissue are made out of, calcium and phosphorus. So when we implant HA in the body, our body thinks that that's part of the bone. It does not recognize that it is a foreign body. But if we put steel, for example, titanium, our body knows that it is a foreign body, okay, because it is not compatible in that sense, right? It does not have calcium, it does not have phosphorus. All right, so that's where we can use hydroxyapatite. We can use it as a coating over titanium. So when we coat titanium with hydroxyapatite, our body thinks that that's part of the bone, right? And you have osteointegration, you have flesh and bone and the hard tissues growing over it. The other class is the tetragonal zirconia. This zirconia ceramic, it is also known as ceramic steel. It's a very hard, strong material, and it can be used for both mechanical and clinical application as well. All right. Hydroxyapatite is known as a bioactive. When we say bioactive, means it supports bone ingrowth, meaning that it interacts with the hard tissue, right? Tetragonal zirconia, it's bioinert. What it simply means is that it does not interact at the same time. It does not cause any problem when it's implanted in the body. It does not corrode in that sense. So no corrosion, so it's non-toxic, right? If you compare to metal, metal can corrode, and that can be toxic to the body. Right, so part of my work is to basically, I talk about sustainable development. So we look at how we can convert waste material, natural waste material, bio-waste material like eggshell, for example. We can convert this eggshell into hydroxyapatite, into nanoscopic powder. We can incorporate microwave technology into it. So this is all part of R&D, and eventually we can use this calcium phosphate based powder to do anything we want, whether we want to make solid implant or we want to use it as a coating onto a titanium stem, all right, through the application of heat and of course mechanical treatment process. So all these part of mechanical engineering as well. It's a branch of mechanical engineering. This just to show how the material that we develop, I develop in the lab. It resembles the human tooth, the enamel of a human tooth. So if we look at the X-ray profile, very similar profile. All right, and that's why our body thinks that when we use the hydroxyapatite in the body thinks that it is part of the hard tissue, the part of the bone. Of course, we have done study implantation in animal. So this is a tibia of a rabbit, and you can see that the hydroxyapatite, you have very good fusion between the wall of the implant and the surrounding bone. All right, so it does not elicit any behavior such as any irritation or any side effect. When it's implanted in living tissue. So these are some properties. So we can engineer the properties to resemble the bone, right? Or it can be even stronger than the bone. So it all depends on what we want to do and which part of the body that we want to sustain loading. So we can actually engineer the material to suit any application. We can even make it porous if we want it to be porous and lightweight. These are some of the properties showing the density with microwave. So no worries about the graph. What it simply shows is that microwave processing is faster, right? In less than 30 minutes, you get very high density in comparison with conventional processing, which takes typically 24 hours. So this is all part of R&D. We look at the microstructure, we engineer the microstructure, we try to make it as fine as possible into nanoscopic range so that it can give very strong, able to sustain high loading conditions and so on. We look at microstructure and whatnot, right? Okay. Right, in terms of zirconia has a unique healing ability. When there's a crack trying to propagate through the material, it actually arrests the crack. So we call that transformation toughening. And this is only unique in tetragonal zirconia. All right, and we capitalize on this behavior of this material. remember I explained just now, part of our studies in mechanical engineering, we learn to understand behavior of material, and this is where we apply it in our further studies, like in our PhD studies. We study zirconia and we understand the material behavior and how it responds to loading. And we capitalize on that response in order to make devices. And because of the self-healing mechanism in zirconia, we can use this in all sorts of components, because if there is a crack trying to propagate, it will self-heal. It will basically shield the crack from propagating. So these are some evidences to show the bulging effect. As you can see, these are the transformation toughening effect. Normally, this is a typical viscous indentation. You normally get crack coming out from here, but in this case, you don't see cracks, right? You don't see cracks coming out from the corners, because you have the self-healing mechanism taking place, and you have this bulging effect. So what happens is that the crack cannot propagate, right? It gets shuts, and you see the surfaces bulge, right? And this is the effect of crack arrest. All right, so again, showing the superiority of microwave processing, so don't worry about it, right? Again, in 10 minutes, we can complete the whole process rather than taking 24 hours. We get very good modulus of elasticity. We get good viscous hardness as well. We can use it for solid oxide fuel cell. We can develop fine microstructure with microwave processing. So these are all part of the technology that we engage in. So as part of our training as mechanical engineers, we exploit technology. Remember, I talked about industrial revolution, right? So we use latest technology to assist in our R&D as well, all right? And we see how we can capitalize on this technology in order to improve behavior, or in order to engineer the structure to do what we want the structure to do. All right, so we also use doping effect and with microwave effect. So, this is where analytical thinking comes in, right? I mentioned earlier that mechanical engineering provides, the graduates with this critical thinking mind. And that's where in research we apply, we look at, okay, how can we jump from here directly to here? And if we apply microwave, it is not possible to go from here to here, right? You probably can go from here to here. So in order to reach very high densification, we first dope the material, and then we microwave the material, right? So it's a two-step approach using two different theories or ideas, right? In order to improvise the material so that we can sinter at low temperature, as you can see, at 1100. If we can sinter high density at low temperature with microwave within 10 minutes, we save a lot of energy, right? We save a lot of energy, and therefore we can make cheap component. And the component is strong and able to sustain the loading condition. And that's part of my research, is to always look at sustainable development, economical processes, and try to make eco-friendly product that is cheaply available to the public. Right, so many applications for tetragonal zirconia. We can use it for grinding media, sleeve, valve, dies, as palm face seals, polishing support, seal rings. I mentioned just now about the total hip replacement. We can make the femoral hip out of ceramic. In research, it has been shown that when we use ceramic, the friction is very low, and therefore patients having the implant may not need to go through surgery again in order when the implant is loosened because of friction and so on. So you can prolong the lifespan of the implant when you actually use it in the body, okay, because you keep the friction low. Zirconia knife, these are very typical nowadays. You can find it in the marketplace and cheaply available, especially made in China, in Korea, right? So you can have tetragonal zirconia knives, and these blades are sharp. They don't need to sharpen, right? One time sharpen and it lasts for life, and it does not corrode. I have a couple of them at home. I use it to cut vegetable, cut meat, and so on. And then it's very sharp. You can use it as a blade for shaving blades, surgical blades, and so on. So this is something that I've made a long time ago when I was working with the industry, to make ceramic blades and knives for the customers. And of course, cutting tools, we can use zirconia cutting tools to cut metals because of their hardness and strength. It can use for turning application. So these are cutting tools that I've developed for semiconductor industry. This is maybe 20 years ago, right? And I have to design the whole process. I mean, because the material comes in powder form, and I have to think about near net shape forming ability to form the component without needing to undergo surface finishing and so on, because grinding of ceramics is very expensive, because ceramics are very hard material and you have to use diamond tool to grind them. So in order to avoid excessive grinding, we have to do near net shape formation. So we need to design the mold and die in order to press directly into its shape, so that after we sinter it, we will get the final shape of it. So a lot of thought process have to be put into the development of the cutting tool. And of course, dental implant. Yeah, we as I mentioned that as we age, we lose our tooth, for some reason, maybe through accident or we lose calcium in our body as we age. And eventually we may lose our tooth, and therefore, we may want to put implant, and that's where we can use zirconia implant, to replace the tooth that is gone now, basically, it helps with that. I've also worked with industry. This is an industry in boiler industry in UK, right? So what happens is that they develop a new line of boilers, and they have problems with the older version of their boilers, whereby their valve are corroding. The boiler valve inside the boiler, they are corroding. And so they came across some of my papers because I do some study looking at the effect of steam onto zirconia, and they came across some of my papers, and they contacted me and they wanted to use some of my formulation, okay, to see if ceramic can be developed into valve. And so, I've sent them some samples, and this is at the industry site. They actually fit in steam flowing at 60 bar pressure at temperature of 274 in the site. Now they compare, I gave them a commercial material, right? So this is a commercial material. After 30 hours of exposure, it crumbled into pieces. So something solid like this gone into powder after 30 hours of exposure in the steam. But my formulation survived 1,000 hours, okay, intact, and did not break into pieces. All right. So this is possible because of the formulation of the material itself, right? So you understand the behavior, and we look at how we can avoid the steam attack onto the material. Now this is, as I said, part of research. We understand the interaction of water, in this case steam, with the material. And once we understand the interaction, we then try to block that interaction. And if we can break that bond, that hydroxyl, like in this case hydroxyl, if we can break that chemical bond, we don't allow hydroxyl to form a bond with the zirconia or the element within the material, then you can avoid stress being built up in the material. This commercial material breaks into pieces is because of stress development, because of the hydroxyl forming a bond within the constituent in the material, and that's why it breaks into pieces, right? So that's what we do. We understand the behavior, and then we are able to think about, okay, how can we avoid that interaction? And subsequently, I made valves, zirconia valves, and they have a couple of design. So I went for the option 5, right? Because again, remember just now I talked about ease of manufacturing. We have to appreciate and understand the behavior of the material. So ceramic, it's very difficult to make it into specific shape, like option 4, for example. We have we have to think about the tooling and how we are going to then remove the material. Remember, I said that we don't want to use grinding. I could have made a block and grind it into shape, but that's going to cost a lot. I got to use diamond tooling and so on. So I think about near net shaping, and that's where we need to make the mold, the die and mold, and we press it into shape. And that's why the cone option 5, is the best option. All right, and of course they have specific dimension which typically we can control, and we are able to build those, make those components. So these are different color because of formulation, right? Because of formulation, of course, the ingredient that we put in ended up it's becoming blackish in color, but it does not matter, right? Most importantly, it's that when it is being used in the design, it has to function. This is another company that I work with in Thailand to actually make porous bioceramic using 3D printing. You know, 3D printing now is quite famous. So we utilize the technology, all right? We try to 3D print ceramic material, we make it porous. Now this is very good. We can control the pore, like in this case. We would be able to allow infuse of veins and blood vessels and so on when it is implanted in the body. Right, and this assists eventually mechanical locking, and this material scaffold, we call it a scaffold because they are porous. When we place it in the body, it allows the ingrowth of flesh, as I mentioned, and it gives that mechanical locking. Right, so this is something that we have used. We use 3D printing because 3D printing we can precisely control the pore morphology, and you can see very symmetrical morphology that we can get, right? So that's something that we are working on currently. I work with this Thailand company to produce this bioceramic. The other thing that I worked on is trying to convert metallic beads into ceramic beads, right? So these are used for dental application. You know, when you lose your tooth, you need to put an implant in your jaw. You need to actually drill holes and so on. And so in the past, what happens is that typically dentists, dental surgeons would use metallic implant, and metallic implant has the issue of, it wears off because the bone are strong. And then it also, because of friction, you know, it also gives out a little bit of iron powder, so it can cause health issue and so on. So we look at developing ceramic tools, and these are zirconia drill bits that has been developed by the company and being used currently in dental application. All right, so you can use these drill bits, which are purely ceramic. They are basically bio-inert, and they are very sharp, and they are able to allow the dental surgeons to actually control the holes that they want to drill precisely and to whatever depth. And because they are very sharp, the penetration is fast. All right, so of course the patient will not feel the pain because, you know, they are the area where surgery is being done, it's being numb. But then with the ceramic drill bits, you allow the procedure to be done quick. All right. So these are some close-up views of some of the drill bits that have been developed. All right. So in terms of my conclusion, right? Mechanical engineering education is unique as it not only prepares students to be holistic graduates, it also instills critical and creative thinking in graduates. And I believe in this because, you know, I mean, I've seen a lot, not just myself, I've seen a lot of colleagues who have undertaken mechanical engineering. They are critical thinkers. You know, they have creative mind. You know, they look at structures and they think about how they can make things better. Right, and that's where mechanical engineering provides us that ability. The going through the education, it instills that ability in us to think critically. All right, and there's a constant demand for better livelihood and human comfort. This puts great emphasis on improving machines, right? Dealing with complex manufacturing processes. If you look at the TBM, it's not perfect. There's a lot of sluggish processes. It can be improvised, and that's where mechanical engineers, I'm sure 10 years down the road, you will see a more advanced TBM machine being used in making tunnels and so on. All right, so the push for better livelihood, better human comfort requires mechanical engineers to think outside the box. Okay, so therefore there's huge potential and avenues for aspiring mechanical engineers. As I said, sky is the limit, right? So you can venture in areas like nanotechnology, micro electromechanical systems, bioengineering, and so on and so forth. All right, and of course consultancies. You can always ended up in consultancies, provide consultancy services, or even in production, in manufacturing, and so on and so forth. So eventually, what we expect from our mechanical engineers student is that as you enter the program, we hope to instill the required graduate attributes, and here I have the 12 graduate attributes that we hope our graduates will eventually attain at the time of graduation, and eventually as they progresses in industry. Our hope is that they become professional engineers. But of course, you know, this is our hope because that's what we are nurturing, right? But of course, there are students who graduate with mechanical engineering, they move into administration, they move into banking, they move into marketing, and that's perfectly fine because we know that mechanical engineers can do a lot of function, not just moving into professional engineering, but also to serve industry and society in other ways as well. All right, so this is our expectation for our graduates. Okay, I think I come to the end of my presentation. Let me finish off with a last video on a dental implant. All right, so let me take you through just maybe 3 minutes video. In this video, you will see the basically the implantation, right? How ceramic tools are being used and dental implant are being used in order to plug the hole, you know, in the jaw when someone loses a tooth. All right, so let me just play the video. Can you see the video?
Yes, sir.
All right, so there's a bad tooth and that tooth is being removed. Okay. That's it. Thank you very much.
Thank you, sir.
Thank you, sir. Now we have a question from one of the participants to the speaker.
Okay.
What is the amount of job opportunities in mechanical engineering, particularly in terms of manufacturing sector of the cars and automobile sectors?
Of course, yeah. Of course, there's the huge potential. I mean, automotive new models are coming out almost every year, right? So the market potential is huge. I mean, mechanical engineers, even up to today, there are a lot of potential jobs. If you look at the newspaper, if you look at advertisement agencies, there will always be avenue for mechanical engineers. Every year we produce a lot of graduates in Malaysia, and as far as I know, within 3 months, the statistics have shown within 3 months, 90% of our graduates get a job. Mechanical engineering has the highest percentage.
Okay, sir. Well, sir. Thank you, sir. Thank you for exposing and throwing a light on the importance and recent advancements in the mechanical department, R&D, core concepts, and latest technologies of mechanical engineering, and its a wider range of applications in different domains of engineering. I'm sure today's your sessions will really help participants while choosing mechanical engineering as a course in engineering.
Yeah.
Again, thank you so much, sir, for being with us today and joining hands with BMSIT and M effort in making this event more meaningful. Now I request Dr. K.M. Satish Kumar, sir, Head Department of Mechanical Engineering, BMSITM, for the concluding remarks.
Sanmesh, can we have some questions there? Any questions from the audience?
No, sir. Actually, we requested, but only one questions we have got.
Participants, any questions from your side to the respected speaker?
Any questions? I request all the participants, if you have any questions to ask to the speaker, please type it in the chat box.
Yeah, maybe I just probably among the students, probably there are female students, right, who wanting to do mechanical engineering, right? And all I can say is that mechanical engineering is not just for guys. It is also open for ladies too, right? There's a lot of things that you can do in mechanical engineering. If you look at the videos that I've shown just now, just to give you an idea of what mechanical engineers do, right? Once you get your degree, you are the brain behind the projects. You don't really go to the site and do all those work. Those are the workers that carry out your work, your ideas, your design. So there's a lot of scope for ladies, for girls who aspires to become mechanical engineering. My daughter wants to become a mechanical engineer. Thank you.
That's great, sir. Thank you. So now I request K.M. Satish Kumar, sir, for the concluding remarks. Over to you, sir.
Yeah. Thank you, Dr. Sanmesh. Now we're not expected. This is the best of the option that which you could able to start off the international webinar based on the career prospects of mechanical engineering. So a great beginning that we have made today. So I'm very much thankful to Professor Ramesh Singh sir for his wide range of valuable insights that you have given for the mechanical engineering discipline. So you have started with the marvels of mechanical engineering, because that itself is great. And you took the examples of all those different marvels, which you have covered almost all the components that of mechanical engineering discipline is going to be there. From the truck to the spaceship to the tunnel boring machine. And to continue with, you explained about the knowledge profile, the basic mechanical engineering should supposed to possess, the core profile that you talked about. And you have made a strong comment that the mechanical engineering graduates are going to be, or the mechanical engineering aspiring students are going to have a strong analytical thinkers. who are capable of solving complex engineering problems. So it's a takeaway for all the participants. So if you want to be a strong analytical thinkers, please do join to our department of mechanical engineering. So this is my observation and suggestion. And also, sir spoke about the engineering application and broad spectrum of ME function, and also career prospects, and also put a light on the R&D prospects, and what sir has done with respect to the zirconia and its medical related application. With that, I can just able to say that general concept is mechanical engineering is gender biased. That also he has clearly told it's not, and it's open to everyone. And mechanical engineers, a general notion is that we work only on the machines. No, we work on the machine and also in the medical field. So the amount of the videos that he has shown is can be very clearly mentioned that the medical applications are also in the forefront of the mechanical engineers. So it's really such a diversified field is our mechanical engineer. So we are all proud to be a mechanical engineer. And through this forum, I just want to say to all my those who have joined that we have a better opportunity in the mechanical engineering discipline. The department and our students have done fantastically well in the national level hackathons and all, and our alumni are globally present, and they're all doing very well for the alma mater. And so this is a very good thought that professor has put forth to all the participants to keep them know about the prospects of mechanical engineering. So I wholeheartedly thank you, sir. I wholeheartedly thank you for all the effort that you have put to make sure that the students will not have any doubt as such. That was the intention of our the whole of this webinar series. So once again, from the Department of Mechanical Engineering and from the BMS Institute of Technology and Management, and from all the trust, BMS Education Trust, I wholeheartedly congratulate. Thank you for your time that you have spent in this day, sir. Thank you very much.
Thank you. Thank you.
I take this opportunity to thank our respected principal, Dr. Mohan Babu GN, for all his support and all his innovative thinking to reach to the needy people. Okay, that is the need of the hour. So the very essence of this program is to make sure that the students should not have any dilemma in choosing any of the discipline of engineering. Okay, be it mechanical, be it computer science, or be it A&ML, whatever it is. So that was the motto with which this was started. So thank you, sir, for all your support and all your encouragement in making these programs to happen in our institute.
Yeah, thank you very much. Thank you, Dr. Ramesh Singhji. Thank you very much for being with us. And it was a wonderful talk. I hope we'll have a wonderful and very productive long-term relationship. Thank you very much.
Thank you, sir.
Thank you.
Thank you. So I take this opportunity to thank our respected Vice Principal, Dr. H. Govind Raju, sir. Okay. So he is most of the time instrumental in making all this to happen, and he is all supportive and in this activity. So thank you, Dr. Govind Raju, sir, for all your support in the activities of the department.
Thank you, Sitesh. Thank you, Ramesh Singh, sir, for your valuable talk.
So at the outset, I will also thank all my dear colleagues, the Dean, HODs, and all my dear colleagues, those who have joined, teaching and also technical. At the end of the session, I just like to say that to all the participants who have joined, okay, now it's a bright career ahead for you, bright prospects ahead with you, the mechanical engineering discipline. You have gone through with the various aspects from the basic thing to the R&D. So this will be a beginning for you. Make a best choice of the best choice, and join through all the sessions. I kindly request you to join through all the sessions. A week-long festival, I can say, about shaping your career, shaping your educational career in a better way. So with this, with the permission of Dr. Ramesh Singh, Principal and Vice Principal, I take this opportunity to thank one and all who has supported. Thank you, Dr. Sangmesh, for your wonderful coordination with all the members in this particular program. Thank you all. Thank you again, Dr. Ramesh Singh. Thank you, sir.
Thank you.
Thank you, sir. With this, we are closing the today's session. I request all the participants do to visit our Center of Excellence and Industry Attached Labs in Toyota and BMW, which is located in BMSITM in the Department of Mechanical Engineering. With this, I will be closing. At the end of the session, we will be sending you a feedback form. Please go through it and fill the same and send it. Thank you. Thanks for joining, sir. Thank you, sir.
Thank you. Have a nice day.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir. Thank you.
Satish sir, thank you. It was nice.
Thank you, sir, for joining.
Sangamesh?